Good evening, students. Welcome to 11th Standard Chemistry video class. We are discussing Lesson 6, Gaseous State. In our last video, we completed the introduction to the lesson, definition, and the units for pressure. In this video, we will discuss the gas laws. First, we will start with Boyle's law. Here we are having the statement for Boyle's law. At a given temperature, the volume occupied by a fixed mass of a gas is inversely proportional to its pressure. This is the statement for Boyle's law. Again I repeat, according to Boyle's law, at a given temperature, the volume occupied by a fixed mass of a gas is inversely proportional to its pressure. This is a statement for Boyle's law. Now we will discuss the Boyle's law detailedly. Boyle's law, pressure-volume relationship. Robert Boyle performed a series of experiments to study the relation between pressure and volume of gases. Robert Boyle, the scientist, performed a series of experiments to study the relation between pressure and volume of gases. Hence, the pressure-volume relationship is given by the scientist Robert Boyle. Therefore, the law given by the scientist is said to be Boyle's law. Just now only we gave the statement for Boyle's law. Now we will discuss the Boyle's law experiment. Consider the following picture which explains the Boyle's law experiment. From the above picture, mercury was added through the open end of the apparatus such that the mercury level on both ends are equal, which is shown in the picture A. Consider the picture A. The apparatus contains one end to be opened and another end to be closed, in which the mercury was added through the open end of the apparatus such that the mercury level on both ends are equal. It is given in the picture. In the picture, yellow color on the left side indicates the volume of air, which is given by V, where the gray color indicates the volume of mercury. Add more amount of mercury until the volume of the trapped air is reduced to half of its original volume, as shown in the picture B. In the apparatus, add some more amount of mercury until the volume of air in the closed end is reduced to its original volume. It is given by V by 2. Addition of mercury reduces the original volume of air in the closed end. It is reduced to half of its original volume. It is shown in the picture B. The pressure exerted on the gas by the addition of excess mercury is given by the difference in mercury levels of the tube. Initially, the pressure exerted by the gas is equal to 1 atmosphere, as the difference in height of mercury levels is 0. For the picture A, the pressure exerted by the gas is equal to 1 atmosphere, as the difference in height of the mercury levels is 0. In picture B, when the volume is reduced to half, the difference in mercury levels increases to 760 mm. Now, the pressure exerted by the gas is equal to 2 atmosphere. Here, we are having the two terms, namely pressure and volume. As we move from picture A to picture B, the pressure of the gas increases from 1 atmosphere to 2 atmosphere, as the difference in height of the mercury levels increases from 0 to 760 mm, where volume of the gas is get reduced to its half from the original volume. From the above experiment, the conclusion is pressure increases, volume decreases. From the above, Boyle concludes that at a given temperature, the volume occupied by a fixed mass of a gas is inversely proportional to its pressure. This statement is said to be Boyle's law. It is present in last 4 lines of the paragraph. Again I repeat, according to Boyle's law, at a given temperature, the volume occupied by a fixed mass of a gas is inversely proportional to its pressure. The mathematical expression for Boyle's law is given here. Volume V is inversely proportional to pressure P. It is given in equation 6.1. T and N are fixed. The capital letter T and the small letter N are fixed. T is temperature, N is number of moles. In order to remove the proportionality symbol, we have to add one constant. After adding the constant, equation 6.1 becomes equation 6.2. It is V equal to K into 1 by P, where K is proportionality constant. Hence, the expression V equal to K into 1 by P, which is given in equation 6.2. When we rearrange equation 6.2, it becomes PV equal to K. It is given by equation 6.2a at constant temperature and mass. Boyle's law is applicable to all gases regardless of their chemical identity, provided the pressure is low. Boyle's law is applicable for the gases with low pressure. Therefore, for a given mass of a gas under two different set of conditions at constant temperature, we can write P1 V1 is equal to P2 V2, which is equal to K. It is given by the equation 6.3. Equation 6.3 is obtained from equation 6.2a. PV equal to K is equation 6.2a. For a given mass of a gas under two different sets of conditions at a constant temperature, equation 6.2a becomes P1 V1 is equal to P2 V2, which is equal to K. Boyle's law is also given by graphical representation. This is graphical representation of Boyle's law from the expression pressure is inversely proportional to volume, or P is inversely proportional to V. Here the x-axis is given by 1 by V, where y-axis is given by P. It gives the straight line. This is also graphical representation of Boyle's law from the expression pressure into volume is equal to K, or otherwise PV equal to K. Here the x-axis is P, the y-axis is V. It gives the curve. The pressure volume relationship or the PV relationship can be understood as follows. The pressure is due to the force of the gas particles on the walls of the container. If a given amount of gas is compressed to half of its volume, the density is doubled and the number of particles hitting the unit area of the container will be doubled. Hence, the pressure would increase twofold. Here, if a given amount of gas is compressed to its half of its volume, the number of particles hitting the unit area of the container will be doubled, which means pressure is doubled. From the above, volume decreases, pressure increases. Next topic, consequences of Boyle's law. The pressure density relationship can be derived from the Boyle's law. Boyle's law also gives the relationship between pressure and density. It is given here. P1 V1 is equal to P2 V2 from Boyle's law. Already we know that density is equal to mass by volume, where volume equal to mass divided by density. It is given for two different sets of conditions. Here V1 equal to m divided by d1, V2 is equal to m divided by d2. Substitute the values in the equation. We will get P1 into m divided by d1 is equal to P2 into m divided by d2. Here m is mass, d1 and d2 are the densities of gases at pressure P1 and P2. Now cancel m from both sides. We will get P1 by d1 is equal to P2 by d2. It is given by equation 6.4. In other words, the density of a gas is directly proportional to pressure. Again I repeat, the density of a gas is directly proportional to pressure. Here we related pressure with density. Hence we completed the consequences of Boyle's law. Next we will discuss the problem based on Boyle's law. In picture 6.3, let us find the missing parameters: volume in 6.3b and pressure in 6.3c. Here in this problem, T represents temperature, P represents pressure, V represents volume. In picture 6.3a, P1 equal to 1 atmosphere, V1 equal to 1 decimeter cube, T equal to 298 Kelvin. In picture 6.3b, P2 equal to 2 atmosphere, V2 we have to calculate, T equal to 298 Kelvin. In picture 6.3c, P3 we have to calculate, V3 equal to 0.25 decimeter cube, T equal to 298 Kelvin. From the question, we can understand that the problem is based on Boyle's law, because we are having temperature value constant, but there should be changes in pressure and volume. Solution for the problem. According to Boyle's law, at a constant temperature for a given mass of a gas, pressure volume relation is given by P1 V1 equal to P2 V2 equal to P3 V3. Substitute the values. After substituting the values, we will get 1 atmosphere into 1 decimeter cube is equal to 2 atmosphere into V2, which is equal to P3 into 0.25 decimeter cube. You have to take the values P1 V1 and P2 V2, from which we can calculate V2 value. For that, 1 atmosphere into 1 decimeter cube is equal to 2 atmosphere into V2. After rearranging, we will get V2 is equal to 1 atmosphere into 1 decimeter cube divided by 2 atmosphere. After simplification, we will get 0.5 decimeter cube. Therefore, V2 is equal to 0.5 decimeter cube. Next, we have to calculate P3 value. For that, take V1 P1 and V3 P3 values. P3 into 0.25 decimeter cube, which is equal to 1 atmosphere into 1 decimeter cube. After rearranging, P3 is equal to 1 atmosphere into 1 decimeter cube divided by 0.25 decimeter cube. After simplification, we will get 4 atmosphere. Therefore, P3 is equal to 4 atmosphere. Hence, we completed the problem based on Boyle's law. Here we calculated V2 value and P3 value. Hence, in this video, we completed the topic Boyle's law. Let me stop up to this topic. The remaining topics that we will discuss in our next video class. Thank you.